Annyeong. Welcome back to my channel. Today we are going to discuss about higher order derivatives. First, remember that the higher derivative of any given function is always equal to 0. So if a function f is differentiable, then its derivative f prime is also called first derivative of f. If the function f prime is again differentiable, its derivative denoted by f second is also called second derivative of f. Similarly, the third derivative of f denoted f third is defined as the third derivative of function f. In general, the n derivative of f is the derivative of the n minus 1 derivative of f. If y to the power of n, f quantity of x, other notation for the second derivative are f to the power of n or d squared y over dx squared. So let's apply this to our example. So first, we need to find the third derivatives of function y is quantity of 3x minus 2 times quantity of x plus 5. So our we need to use the chain chain rule. So y prime. So our first derivative is this is our a and this is our b. A, b. So copy first the a, which is the quantity of 3x minus 2 times the derivative of b, which is x plus 5. So the derivative of our b is 1. Plus, again, copy the b, multiply by the derivative of a, which is 3. So our first derivative is 3x. First multiply. So quantity of 3x minus 2 times 1 is 6x. Plus multiply the quantity of x plus 5 times 3 is 13. So our first derivative is 6x plus 13. So next, we need to find the second derivative. So for our second derivative, we are going to base our first derivative, which is 6x plus 13. So our second derivative is 6. Then our third derivative is 0. So the third derivative that we need to find is 0. Next example is find the seventh derivative of function x to the power of 7 minus 6 to the power minus x to the power of 6 plus x to the power of 5th. So first we need to find the first derivative. So we need from the given function, we are going to use the power rule. So our first derivative is 7x to the power of 6, which we get from bring down the power, which is 7, then the power the power 6, we get it from 7 minus 1, so which is 6, minus 6x to the power of 5th plus 5x to the power of 4th. So this is our first derivative. So we need to find the second derivative. Again, the power rule is we need to use the power rule. So again, 6 times 7, which is 42, then minus 1 is 5. So 42x to the power of 5th minus 6 times 5 equals 30. 5 minus 1 is 4. So minus 30x to the power of 4 plus 5 times 4 is 20 minus 1 is 3. So our second derivative is 42x to the power of 5th minus 30 times 4 plus 20 times 20x to the power of 3rd. So we need to find the next derivative, which is the third derivative. So again, use the power rule. 5 times 42 is 210x. So 5 minus 1 is 4. Minus 3 times 30 times 4 is 120. 4 minus 1 is 3. Plus 20 times 3 is 60. 3 minus 1 is 2. So our third derivative is 210x to the power of 4 minus 120x to the power of 3 plus 60x to the power of 2. So next, we need to find fourth, because the question is find the seventh derivative. So we are going to find the seventh derivative. So proceed, we need to find again the fourth derivative. So again, use the power rule. 4 times 210 is 840. 4 minus 1 is 3. Minus 120 times 3 is 360. 3 minus 1 is 2. No, it's plus. Here, I forgot. It's plus. Plus 60 times 2 is 120x. Because 2 minus 1 is 1. So consider, it's okay if we don't write 1, because x is considered the power of 1. So again, let's proceed to the fifth derivative. So again, use the power rule. So 840 times 3 is 2520. 3 minus 1 is 2. Then 360 times 2 is 720. Plus 120 times 1 is 120. So our fifth derivative is 2520 to the power of 2 minus 720 x plus 120. So next, we need to find the sixth derivative. So our sixth derivative of the function x to the power of 7 minus x6 plus x5 is 250 2520 times 2 is 10,080 minus 700 times 1 is 720 times 1 is 720. So our sixth derivative is 10,080 minus 720. So our fifth derivative, which is asked. So this the seventh for the seventh derivative is 10,080 times 1. So the seventh derivative of the function x to the power 7 minus x to the power of 6 plus x to the power of 5 is 10,080. So that's all for today's discussion. Thank you for watching.